Hello dear students, good afternoon. How are you? Are you okay? Can you hear me? Okay. We successfully finished the chapter 1 and now we can start chapter 2 of distributed systems. But let me load an assignment now before I start the teaching. I want to load an assignment. It's your first assignment, and I ask you to summarize the important contents of the first chapter in one page. Okay, it's easy. You just should summarize the important contents of the first chapter in one page. Of course, your summary should be typed in Word Office, okay, and uploaded in PDF format. I think it's a simple task and 1 week should be enough to do it. Shouldn't be? So, I'm uploading the assignment now. Okay, done. I did it. Now you can see the assignment on the website, Darsa. If you go to Darsa website, you can see the assignment. It's an easy assignment, I think. It's very easy. And you have 1 week. You have 1 week left to do it. Can you hear me now? So why have you typed no sound? Okay. Could you see the assignment? I just uploaded it. Very good, very good. Okay. So, chapter 2 is about architecture. In distributed systems, we have different software components, different and various software components, and software architecture tell us how the various software components are to be organized. Okay, and hardware or system architecture tells us about how to install and implement these software components on a real machine. So this chapter is all about architectures. So the organization of distributed system in general fall into two categories: software architecture and system architecture. I said that software architecture is about logical organization of the collection of software components, logical organization. And the system architecture is about actual realization of a distributed system. It means how to implement logical software components in a real machine. Why we have different software components, we must solve the complexity because it's complex. To manage this complexity, it is very important that the system are properly organized. And I again repeat that there are several ways to view the organization of distributed system, but it's clear enough to distinguish between logical organization and system architecture. Firstly, we need to prototype software components. We need to prototype software components. That is software architecture. Secondly, we should place those software components on a real machine. That is system architecture. Got it? Not really? Okay. Let me give you more explanation. Assume we have a distributed system, okay? According to the definition, a distributed system is a collection of independent computers that users can see this system as a single coherent system, okay? So we have a network, we have different machines, and we have different applications. Our system, our distributed system, in one view, is created from different software components. software components, software parts. Okay, so we need to prototype these software components. We need to logically organize these parts, these components. It is exactly software architecture. And then we should implement those software components on a real machine. It is system architecture. That's it. So, with this definition, I think it's now clear for you to understand these two architectures of distributed system. In this chapter, we study these two architectures. Software architectures, about logically organization of the collection of software components, and system architectures, about how to implement, how to place those software components on real machines. What is software component? Everything. For example, interfaces, software cores, I don't know, managing network, all things related to software. These are software components. How to communicate in the network between different machines, how to make fault tolerance, for example. Yes, they are programs, they are software. As the name implies, they are software components. So, we begin our discussion of architecture by examining the logical organization of systems. The logical organization of systems, architectural styles, logical. It is called software architecture. The concept of architectural style is very important. Such a method includes the components and how the components are connected to each other, and the exchange of data between components, how they can communicate, and finally how to integrate these factors to form a single system. It is all about software architecture. So in general, there are 4 styles of architectures in distributed systems: layered architectures, object-based architectures, data-centered architectures, and event-based architectures. So we are talking about logical architectural styles. As you can see, it's very similar to network architectures. Layered architectures, it means we use different layers in our software components. Object-based architecture, data-centered, and event-based. I want to talk about these 4 styles in detail. Firstly, let me talk about layered style or layered architectures. The idea is very simple. Components, software components, are organized in a layered format. Where a component in a layer can do a down call, a lower layer. It means each layer can request from the bottom layer. And usually wait for answer. It is usually layered architecture. So in this model, control flows from layer to layer. Requests go down and results go up. Again, requests go down and results go up. The left picture you can see. Each layer can request from the next bottom layer, and the result will go up. But in object-based architecture or service-oriented architectures, the right picture, this style is based on an arrangement of loosely coupled objects. It is less structured. Each object corresponds to what we define as component. Here, objects are software components. And the RPC, remote procedure call, or RMI, remote method invocation, can be used to communicate. Some popular examples are Java RMI or web services or REST API calls. These are based on objects or object-based architectures. Okay? Very good. We also talked about data-centered or resource-based architectures. One problem with these two previous architectures, layered style and object-based architectures, is that connecting multiple components can easily lead to an integration nightmare. Because why? Can you guess why? It's about consistency. The consistency is difficult in these two architectures. Alternatively, we can have data-centered architecture. data center architecture, we have one repository of data. One repository of data, and all components can communicate with this repository. So it's an important architecture too. And if I want to give you an example of such architecture, I can name those systems which are based on distributed file systems. Distributed file systems. Another architecture is event-based or publish-subscribe architecture. It's an architecture in which there is a strong separation between processing and coordination. The idea is to view the system as a collection of processes. And in this model, we have different events. Processes publish events, and there is a middleware that guarantee that only those processes who are subscribed can receive the processes, the events. So that is why we call publish-subscribe architecture this type. Components publish events. Okay, events are published by components, and only those components can receive these events that are subscribed in the event. If a component is not subscribed for the event, so it cannot receive it. That is why we say publish-subscribe architecture. Also, event-based architectures can be combined with data-centered architectures. Event-based, this architecture, the left picture, okay, can be combined with the data-centered architectures. I talked about it before event-based architecture. What would be the result? Shared data space. Shared data space. In shared data space, we have a data repository like data centers, and also we have publish-subscribe architecture too. So it's a hybrid of the two last architectures. Is it clear for you? Or guess, yeah, no. Word. So, do you have the book? Do you have the book, the reference book? Yes, good. So if you have the book, please, after the class, please go and study chapter 2. If you read the chapter 2 in your book, it would be clear for you, I'm sure. Okay. And now system architecture. Our previous discussion was about software architecture, and now we want to talk about system architectures. System architectures are generally centralized, decentralized, and hybrid architectures. Hybrid architecture is a combination of centralized and decentralized architecture. So it is system architecture in distributed system. If you remember, I told you that system architecture says that how we can place software component on real machines. Ms. Rasha said, I read it, but I want more explained from you, please. I don't know how I can explain it to you to understand it completely. To me, the book clears the text in a good way, but so let me come back. I want to say in a simple way, okay? In chapter 2, we want to talk about architectures, okay? So, we have distributed system. In general, please keep in mind that distributed system is a collection of software components. So, how we can logically organize these software components? It is about software architecture. It's very easy. We want to solve complexity. When we have many software components, it's complex, okay? So we should organize these software components. And how we can organize these software components? The answer is about software architecture. System architecture tells us about how to place those software components on a real machine. It's system architecture. Okay, so the first issue is about software architecture. How we can logically organize software components. There are four important ways. Layered architectures, we have different layers. Object-based architectures, we can organize software components as objects in our system. It's about logically organized, not physically, logically organized. Data center architectures and event-based architectures. See the system as a collection of events, for example, okay? Layered architectures, look at the left picture. It's about layered architecture. we can put software components in a layer style, okay? So each layer can request something from the bottom layer, and the results will go up to the upper layer. So layer n only can request from layer n-1. Layer 2 only can request from layer 1, request something, okay? And the result in layer 1 can go up only to layer 2. It is an organization of software components. It is called layered style. The right picture shows us object-based style for distributed object system. It means we have different components. We don't have layer here, okay? We organize components, software components as an object here, as objects. So objects can communicate with each other. It is called object-based style. So it's simple, it's not difficult really. The third style was about data-centered architectures, as you can see, okay? Data-centered architecture. Logically organized software components in data-centered architecture. How? Okay, we can imagine we have a data repository, one data repository, okay? All the data is stored in this repository. And all the processes can communicate with this repository to read data or to write new data or to update data. It is data-centered architecture. It's simple. And event-based architecture, here the left picture is event-based architecture or publish-subscribe. We have different components here, software components. Each software component can publish an event or some events, and only some components can receive the event that they have subscribed in the event. عضویت، انتشار عضویت، publish, subscribe، انتشار عضویت. Okay, it's easy. For example, component 1 publishes an event for component 4, okay? But this event is published in a bus. All the components can see the event, but only component 4 is subscribed in this event. So only component 4 can receive and read this event. That's it. Finally, if we combine the event-based style with the data-centered style, we can have a hybrid style called shared database. Picture B, the right picture. Like data-centered, we have a repository of data, and like publish-subscribe or event-based, we can have publish-subscribe policy here. So it is a hybrid. Finished. That's it. It was all about different logical architecture styles in distributed system. Here, well, so we talked about different logically styles of architecture, okay? The logically organized software components in the system. But how to place these software components on a real machine It's about system architecture. We want to talk about system architecture now. And I said to you that we have three main system architectures in distributed system: centralized architecture, decentralized architecture, and a hybrid of these two architectures. First, centralized architecture. The centralized architecture as you can see in this picture, the client can request some services from server. For example, you send a request to a server to do a calculation, for example, to solve a problem, for example. You have a problem and there is a server to solve your problem. Or you want to see a report. So the server provides this report for you. You are a client. Okay? It is client-server model. The client sends its request to the server. And then the server receives the request. It needs some time to provide services, to do some calculation, to do some processes, okay, to provide the service, the request service. And when the service is provided, the server sends the service to the client. It is called reply. Reply. The server provides service and sends it to the client. The client, which was waiting for the result, now can receive the result, and that's it. It's a very simple model called client-server model. It is centralized architecture. Okay, very good. It's clear. As you can see, there are processes offering services. They are called servers. There are processes that use services. They are called clients. Clients and servers can be, and usually they are on different machines. Clients follow request-reply model to use services. It is a model that is called request-reply. Client sends request and server replies. It is called a request-reply model. But this simple model cannot work properly in a wide area network, WAN. Why? Because the network is not reliable. Let me give you an example. Suppose you want to transfer money between your accounts, okay? So, you are using online banking. You are a client and the server of the bank is server. You send your request to the server to decrease money from your account, okay? Look at this picture here. Here you send your request to send money to another account, okay? The server, follow this story please. The server receives your request, provides services and do the calculation. The task is done. So the money is transferred to the destination account here, okay? Now, the server sends a message or reply to the client, to you, to tell you that the operation was done successfully. But here, exactly here, but here, the message is missed because we have noise and our network is not reliable. What will happen? You or the client will not receive any reply here. Okay? The client will not receive any reply here. The client is waiting for the result, but he never received any result. Yes, client is still waiting, Client does not know that the operation is done successfully here. So, what should we do here? What should the client do here? Wait. How much he can wait? How much he can wait? Place timer. So, if we use a timer here, and when the timer finishes its operation, the client can send again the request because the client thinks that his message has been lost and the server never received his message. So if the client repeat to request the server for the operation, what will happen? The server again receives the request and do the operation for the second time. So we have two transfers here between accounts, money transfer I mean, and it's not good. It's not the solution. It's not good. So it is difficult, or better to say, it is impossible to detect that the request message is down, is lost, or the operation was failed. It's a problem in single request reply model in client server architecture style. So, what's the second solution to do this operation successfully? There is solution. There are some solutions, of course, okay? But another solution can be using idempotent messages. Idempotent message or tasks are those tasks that are done one time only. It is not allowed to repeat them. For example, here, look at here, okay? When the client wants to send a request to transfer money to the server, if the message is idempotent, and the server here receives and do the operation and send the reply, and the reply is lost, okay, the client again sends this request, okay, but the server detects that this request was down, so So the problem is solved. The server do not repeat. Okay, so it's a solution, for example. Okay, any question? Another issue with this model client-server is that there is not any clear distinction between client and servers. I mean, some machines can play the server role, but after some time, that machine can be client. So it is not a clear distinct between client and servers in this model. A server in this example provides services for some clients. Okay, but after few minutes, this server can request a service from other machines, so it is client now. Got it? For example, machine 1 is client, okay? This machine requests some services from machine 2. Machine 2 is server here. But 10 minutes later, machine 2, which was server, now requests some services from machine 3. So machine 2 in this situation is client. Okay? So some machines can play client and server roles. Application layering. To complete the client-server style, another style is suggested, which is called a three-layered view instead of two-layered, three-layered view. In this three-layered view, we can have different layers. User interface layer, which contains units for an application's user interface. I'm sure you know what is user interface. UI, user interface. Yes, it's an interface that the user can use it to do an operation. Processing layer, in this layer, the processing, the calculation is done. And data layer, which contains the data, database or other types of data. It is called data layer. This layering is found in many distributed information systems using traditional database technology and accompanying applications. This style is very famous. But let me talk about user interface layer. A simple user interface is only about a string of characters. For example, when you want to use Google website to search something, the interface is a string of characters here. You put some characters and press enter. That's it. It's all the interface you use, okay? We have some more complex interfaces. For example, in Adobe Connect, the application that we are using it now for video conference, okay? The user interface is graphical. So we have menu here, different menu and different selects. It's an interface too. And more modern interfaces are those interfaces that use modern technologies. For example, drag and drop. If you want to share a file, instead of using some menu and selecting and browsing files, you can drag some files on your desktop and drop it in your application. For example, Adobe Connect. Okay, so it is a modern interface too. Anyway, the second level was about processing layer. In processing layer, for example, you entered your query in Google, okay, and you press enter. Your query is sent to Google servers, and in the Google servers, some algorithms will run to find the correct and proper results according to your search query. It is processing layer. How the results are found, we don't know. Google knows, okay? How? It is done by running some complex algorithms in Google servers. It is processing layer. And when the data should be fetched and should be retrieved from the database, so we need data layer here. So Google processing servers are different from those servers that are used for storing data. So we have some servers that computation and calculation and processing is done, and we have some servers to store data only, okay? This level or this layer is called data layer. That's it. It is called three-layered view. Clear? Yeah. In your book, you can see this picture. It is exactly the example I talked about. User interface layer, for example, searching on Google with a string of characters. Processing level, ranking algorithms, query generator, and so on. And data level. Have you heard something about Google File System, GFS? GFS or Google File System. It's a very interesting file system, in fact. Google uses this file system. Do you know, for example, when I talk about file system, I mean, for example, NTFS, FAT, or extended FAT. These are file systems, okay? And there is GFS, Google File System, is a distributed file system that Google uses. Google has invented this file system to use it for its goals, for example, to increase the performance in searching. And about data level, when I say that in data level we use files and databases, do not think about only relational databases. We have different types of databases. You know, if you have passed database course, you know that we have, for example, object-oriented databases, and also we can have fuzzy databases. So we do not have to only use relational databases. For example, when we work with different shapes, for example, circle, square, and triangle, so these are objects, and using object-oriented databases is very useful in this situation. Anyway, multi-tiered architectures. We can stop here, we can finish our session here, and we can talk about multi-tiered architectures and other slides next session. So when is our next session? Wednesday. Do we have a session on Wednesday? Good. So we continue our discussion on Wednesday. Don't forget to do your assignments, to do your homework, okay? It's important. Thank you. Have a good time and bye.